Hello and welcome to Azure Network Security and how we can secure our network resources within Azure. And with me today, I have Klaus Petersen as well, who is a sales manager in Denmark and head of cloud security and software. So Klaus, do you want to say a few words about yourself?
Yes, thank you, Kim, and greetings to Finland, Norway, Sweden, and Denmark, and welcome to our second session on TechThursday series. This is the deep dive content shared by my great colleague Kim, who is organized in our Nordic Center of Excellence together with a group of cloud architects. We will go through lots of practical and technical stuff today. All sessions are available on our webpage to sign up already, so please do that. Recordings also available and also available on our YouTube channel, and those links will be shared, including the presentation. And on top of that, it's going to be, as I said, tech intense session, not a lot of slides. We will have some stuff that Kim, he will just start off and set the scene, and then we will go directly into the portals. And on the end of this session, I will just close down with a few slides and also ask you to have your QR reader or just a browser ready, because we would really like to hear from you how your experience is. So please hang in tight until we end it. And on that, Kim, I will mute, and the floor is yours.
Thank you, Klaus. So for today's agenda, we have a few things. So first off, we're going to go briefly through what's really at stake when we're talking network security within Azure and network security in general. We are going to look into the finding part, which is how can we find the security flaws that we have in our network configuration within Azure. Next up, I'm going to go through a bit on how you can close those flaws and close those doors. And for some of you, the beginning might be a bit basic if you are already familiar with Azure Network Security. So we'll go through a bit of network security groups and a little bit of best practices on how you can secure connectivity there. We will continue that with a demo where we will have a basic security design, and we will enable that design. And after that, we will go further and look into a few more advanced solutions that we can utilize to add additional security, such as web application firewalls and things like that. I mentioned we have a Q&A as well. We will have that at the end, but please do add your questions during the presentation, and we will try to answer them as fast as possible. So let's get started. What's at stake? So when we're talking network security, one of the biggest risks, I would say, is that will get unauthorized access. And this is often due to you have management ports open to the internet that shouldn't be there. This is especially easy to do by mistake in Azure, since if you just click next when you're deploying a VM, you have very quickly opened up, for instance, the RDP port to the internet. And this is bad for, of course, for a multitude of reasons. You're increasing your attack surface here, and you are prone to everything from dictionary attacks to attacks like vulnerabilities in the protocols and things like that. And this might lead to a whole bunch of scenarios, like, for instance, crypto mining. If someone gets a hold of your servers, they have the possibilities to start crypto mining on those existing resources, which will, of course, steal CPU RAM. Same thing, of course, on premises. But the special thing when we're talking about these risks in the cloud is this might incur larger costs. Say you have data egress from this, or you have it could be disks where you pay for the IOPS and things like that. So these might be risks when it comes to crypto mining. Then of course as always, data theft is you're always at risk for that. Also, something we have seen is, especially with servers utilizing very weak passwords and such, and for instance, the RDP port, and maybe no network security at all in front of it, is that people have been using them as data stores. And this is nothing new. I mean, bad actors have always used servers as insecure servers as a jump host, would you say, for files, stolen files, or piracy or whatnot. But there's also a special risk with this when it comes to Azure, because let's say you have a file share or something that you are paying by the gigabyte, or that might rack up costs quite fast. Of course, you're putting yourself into legal risks as well for that, but you also have the data part, because you are paying for data egress. So in that case, that might and that can rack up costs fairly fast. And then, of course, we have things like defacing websites that can, well, really hurt your business reputation. This, of course, this doesn't have to happen through unauthorized access. This can happen through an exploit in the web application. And we are going to look into a bit how we can protect ourselves from this kind of attack as well. But these are just a few examples of what kind of risks you are at when your network is vulnerable. So here up next, we are going to first look into how do you find those vulnerabilities. And actually, for that, we are going to utilize a tool that I talked about roughly 2 months ago in the last installation of TechThursdays, when we went through Microsoft Defender for Cloud. If you haven't seen that, just a quick description of that system. It's a tool set that is everything from antivirus to vulnerability assessment in the cloud to get an overview of the security posture of all your cloud resources, be that servers, be that PaaS instances and whatnot. And it's a tool set that works on both Azure on-premises and also other public clouds. But in this case, we're actually going to utilize a functionality where we're going to look into vulnerability assessment. And there is a special assessment that looks for management ports. So this is the first step that we're going to look into. And before I hop into that, I will just say that, of course, you can do these steps manually. You can go through every single cloud resource and look into it and see if it's safe. But it's very easy that someone deploys something a day after and so on. So getting that bird's eye, I would really recommend looking into Defender and perhaps creating some policies there that also can prevent these creations. But let's take a look on how you can find it. So search for Defender. And for your knowledge, Defender for Cloud, this part of it was also called Security Center a while back. So you might recognize yourself. So I will hop into recommendations. And here I see I have secure management ports. And if we see now, all of my machines, we have 0 unhealthy resources, do have some sort of network security group. We will go into that in just a few seconds, what that is, but you can say they are protected by some sort of firewall rule. But we see that one of these, we do have the management port open within that security group. So we actually do have a security flaw or an increased attack surface there. And we haven't enabled what's called just-in-time access, which I will go through in just a bit as well. But it's basically that simple. So if I want to close them simply, I'll hop in here. And we see I have the unhealthy resource. And I can simply hop into that. I can create a logic app trigger and fix it that way. Or I can simply hop into it this way. And here we see I have the SSH port open and I have the MySQL port open, which triggers that there are some open management ports up here. So we'll get back to this in a little bit. So let's just get back to the presentation. So if we look into securing those, we need to go through a few of the basic tool sets that we have to secure these VNet resources. So first of all, we have network security groups. And what these are, it's a rule set of allow and deny on an IP and port based. So it's basically, you could call this the absolute basic firewall rules that you apply either straight onto the virtual machine on its virtual network interface or on the virtual network subnet level. And this is the absolute basis of it. On top of that, we do have something called application security groups. And what those are, it's a logical grouping of VMs that are based on what sort of service or application that VM is running. Let's say we have 3 load balanced web servers. We can put them into the same application security group, and within then, let's say a subnet level network security group, we can define that application security group that we allow HTTP and HTTPS from, let's say, everywhere from the internet to those destinations. But on that in the NSG, we disallow everything else. So this will mean that even though we might have multiple web servers, we might have a pair of internal web servers on the same subnet, those cannot be accessed from the internet. And an application security group means that we can utilize the same rules at this same just in one NSG and very easily apply that to many machines at once. And if we look into NSGs, how they work with internet-facing traffic, we need to understand a bit on how public and private IPs work in public and private traffic works in Azure. So every single virtual machine does have an internal IP. It could be whatever, 192.168.0.10, something like that. And if you add a public IP to that, it will be straightly knotted to that IP. So I really want to underscore this, because that means, let's say you don't have an NSG or you have a weak NSG. That means that you are basically at the mercy at whatever firewall rules you have set at the VM level. So this is really something you need to understand. And as I said, with NSGs, they are only a rule set that blocks on an IP and a port basis, nothing more. So there's no traffic inspection going on here. There's nothing like that. So this is just the absolute basis for blocking out traffic. If we go further, we do have a functionality that I will show you in a bit, which is how you can lock down traffic to your machine. If, let's say, you have a Windows server that we don't have the possibility to put it on a fully private network. We need to access it momentarily from the internet. Let's say we might not have the possibility to utilize a VPN at whatever site we're on, but we don't want to expose it to the internet. So what we can do is enable just-in-time access for that VM. That creates a rule set for that VM that says RDP and SSH and whatever you configure can be accessed from a specific IP or any IP. You define that on a per machine level. And a user who are allowed to utilize just in time for that machine can request access to that machine. And if that goes through, he will then get a momentarily open port through the NSG. So the NSG will flip from deny to allow to that specific IP on those specific ports for a limited amount of time. The default is 3 hours, but you can set that to whatever. And then it will simply close if you close it yourself or if the time runs out. So I will show you in a bit how that works. This is, I would say, the first way to secure a management port onto a couple of VMs. Next things, this might actually seem very basic for many of you. I mean, I think most of you have been exposed and been working with VPNs. But I really want to underline the simplicity of utilizing VPNs instead of utilizing, let's say, just-in-time access. So say you have a bunch of servers. It could be a couple of web servers and a SQL server, or it could be some sort of internal application that you don't want at all exposed to the internet, but needs to be in the cloud. You have the possibility, let's say in the case of having web servers, that you can expose the port 80, port 443, but when it comes to management ports and things like that, and let's say if you want to access the database, you can utilize a VPN. It's and utilize, for instance, a point to site on that. And I will go through the steps on how to do that, but I really want to underline that it's a very cheap way to do so. We're talking roughly 25 euros a month for 100 by 100 megabit VPN that supports both IPsec tunnels and point to site. In this case, that is certificate-based SSTP. So this means that no matter if you're working from home or whatever, you have a very easy way to actually accessing those servers and managing them. So I also have a third way how you can easily manage servers. That's called Azure Bastion. And the reason I want to go into that in depth today is because we will have a different session that will focus more on Bastion. But to talk a little bit about what that is, Bastion is a web-based RDP and SSH jump host. So you only access it through Azure. It doesn't have any exposure, if you don't want so, to the internet. So it's a fully private connection from within the portal, but we will go through that in more detail further on. So the next point is private endpoints. So private endpoints, they are very, very neat thing when we're talking about PaaS systems such as databases and storage accounts and things like that. So if you are, let's say you are deploying an application, you have, in my case, the demo I will show, I have 2 WordPress servers that will be load balanced, and I will utilize a MySQL backend database. So if you just deploy it, you will get a publicly accessible port, and you can close down that port, of course, with just restricted to a certain IPs, but the communication will still go over a public facing port. So if you want to tighten that sort of communication down, you can utilize a private endpoint, which means that you are creating a read-only network interface in the virtual network that those virtual machines are sitting on, and utilizing then a private DNS zone, you can address that, be that a storage account or whatever, you can address that resource internally instead, and then you can easily close down all access. And in the demo I will do in a short while, I will show you how that works, and we're also going to look into a bit on the network security on, in this case, on MySQL database. Those sort of firewall rules that we will see there you will see them in many other PaaS resources as well. So it's a good example that you can reutilize in other database and storage accounts and so on. So let's hop on to a demo. So what we will do, I have a set of VMs. I have a PaaS database and MySQL database. So we will first of all go through those VMs and look at the current security posture of them. And then we will create an application security group. We will create a network security group that we will apply to the subnet level, and we will just allow access to HTTP and HTTPS on those VMs. And then we're going to look into the MySQL part and look into how we can tighten down the security on that thing as well. We'll enable private endpoints, see how that works. I've written down here, we will create a VPN. So the problem is the VPN takes quite a while to deploy. So we will see if I have actually pre-baked one, but we're going to do a dry run, and then I'm going to show you a bit within the VPN how you configure that as well. And last but not least, we're going to enable just-in-time access for those VMs and set some custom policies for them, like custom port ranges and custom timeframes. So let's hop into the demo. First of all, I'm going to hop into the resource group. So I'm going to first see that we do have a VPN gateway up here. It seems like I do not, so it hasn't been deployed yet. Oh well. So we're first going to look into the security posture today of those VMs. So I've created two VMs. It's two tiny VMs with a public IP each. This might seem a bit strange that I have two VMs with two public IPs, but in further on we're going to actually front these with another sort of application gateway load balancer. So that's a bit in the future. But for now, in this first step, we're actually gonna just secure them as they are. So if we look into the VP1 and we hop into networking, we can see, as we saw before, that we have the SSH port open. We have enabled access to HTTP and HTTPS, and we have enabled the MySQL port. As you can see, we have enabled it from any to any. So the first step would be if we were to only have one machine and didn't want to use ASGs, would be to simply delete these two and either enable just-in-time access or simply change the source to only my own IP. And the MySQL, I would strongly recommend to remove that completely. But what we're actually going to do, we are going to remove this network security group in a bit. So let's go back a bit to the VP2, and we can see we have the exact same thing over here. So the first thing that we are going to do is actually we're going to create a network security group. There we have it. So I'll create one and I will put it on my subscription. I've created a resource group for this demo, and I will give this a name. I'll call it VPSec WordPress security and place it in the same region as my resources are, which is Western Europe. We can utilize tags here if you want to. This is if you want to group your resources by project, set owners and whatnot. I'm not going to do that now, but you're simply going to create this. Do a create. So this will be just an empty rule set. It won't be applied to anything. So if we hop into it here, we can see that it's just an empty rule set. If we look at it, we are allowing traffic that is within the virtual network. We are allowing traffic that is from any load balancers into this, but we are denying any other traffic. So this is basically a shutdown configuration just within the same virtual network. So we will start creating some rules in a bit, but before that, I will create an application security group. So we search for ASG, application security group, which is the logical grouping of the VMs. I'll do a create, same, and let's place it in the same NetSec demo group, and I will call it just VP ASG, WordPress application security group. And the same thing, you can apply tags if you want to. Simply do a review and create it. It should go fairly fast because this object, there's absolutely no logic or configuration needed within this object. We will set that at the VM level. So if we look into it here, we can't do very much with it. It's simply it's an empty object basically. So the first thing we're going to do is we're going to hop back a bit, hop into the resource group, and sort by type, and go down to those two WordPress Linux machines. So I will hop into networking, and I will go into application security groups. I will configure, so this machine will be a part of the VP ASG, and I will save that. So let's just redo the same thing on the other one. So hop into networking. We hop into application security groups, configure it, and we select the VP ASG here as well and save. So now we have now we have the two machines, a member of these two application security groups. Next part we're going to do is actually hop into the virtual network that are housing these two machines. So we see here, we do have these two machines here. And what we're going to do, we're going to go into the subnet config because, as I mentioned, you can apply a NSG on the network interface level or on the subnet level. So we hop into the subnet and we select network security group, WordPress sec or VP sec. Click save. So we'll let this save and we'll simply hop back into WordPress 1, hop into this, and then we see we have two sets of security. So now we have this basic untouched NSG, the VPSec, and then we have the other one, which is the NIC-based NSG. So we're actually going to go into the VPSec now. There's a quick link for that here, and we're going to add some rules to it. So I want to allow to all these machines, to all machines that the source is any. I mean, the source can be anywhere on the internet. The source port range can be, of course, anything. But the destination is an application security group, VP ASG, which means those two machines. So I can either set a custom port, set TCP port, or we have a whole bunch of presets. So in this case, HTTP. The action will be, we'll allow it. We will put it in a priority that is lower than these three, which it is. And I will give it a name, which is allowed HTTP in this case. So we add it, and there we have it. And we'll do another one as well, which is the same thing, but the service in this case is HTTPS. The destination is the application security group. We allow it, and we call this rule allow HTTPS, and we just add it, and there we have it. So if we hop into the machine now, now it should be created. So let's do a refresh of this blade. So now we are on the WordPress 1 machines network site. So now we can see that on the subnet level, we are affected by these rules. So the last thing we're going to do is actually to remove this old rule set to, well, decrease confusion. So I'm going to hop in to remove it. I'm going to hop into the network card, because quick thing about Azure virtual machines, Azure virtual machines are not a single object. They consist of a virtual machine object, a disk, of course, and a network card. The network card on the NIC, then it keeps the network configuration, which could be if it has an IP, a public IP, we will see that there, and the NSG will be attached there. So we hop in to the attached network interface, click on network security groups, and we simply select none. Because now we will be inheriting the rules from the subnet level. So we hop back, we refresh, and now we see that we are affected by these rules over here. So we're going to quickly just look into its friend, VP2. It's there, networking. And we see the same thing. It's affected on the subnet level by an NSG. Let's just hop in and remove that old NSG that came with the image. None, save. Right. So now we basically have removed that port. So now we are allowing port 80, port 443, and nothing else on this. So now we have done that. So now we have secured those machines that we don't have any open management ports. But what we're going to do next is look into the database side of things. So I've deployed a database. Let's just sort by type. There is actually Azure database for MySQL single server. Hop into that thing. And we're going to just look through it a bit. So we see first off, I have enforced SSL, which is a good thing. But let's hop into the connection security part. And this connection security part, it might be called network security on some resources and something like that, but it's usually on the settings and contains the basic security settings. So if you look into what we have here, so first off, we have deny public network access. So this would be the first thing, because right now we are basically allowing everything to connect to this machine. So this would be the first thing. And if we remove, if we take away this, then we basically are removing all access. So I think I have to actually save this. So I won't actually save this right now because it takes quite a while to save these settings. But this is the first thing you should do: deny the public access. Then this little thing, and this is actually kind of neat rule, because this means, let's say you have a PaaS web app service, for instance. That thing can have a variety of IPs, but those IPs lies on an Azure network range. So what I can do is I can allow this. This is by default, but this means, as I mentioned earlier, that access to this service is granted on a network level, basically, from any other Azure service. So let's say you have an attack that originates within Azure, then this is an extra attack surface. So I would recommend put this to no. What you can do is, of course, if you need to quickly gain access to this and maybe do some work on the database, you can, well, add your current IP, or you could, let's say, you consider a rule, so allow debs, for instance. So we call that that's better. Yeah. So we could say 8.2.50 to 8.5.5.10. So within that range, we will allow that. But that's not what we're going to do today. Today we're going to shut down all access but access from the virtual network. So we're going to do this. We're going to hop into the VNet rules, the existing virtual network. So we're going to call this VNet rule something like VNet integration. Okay. Is that better? Yeah. So on the sponsorship, and I'm going to search for my network, which is the this one, and I only have one subnet, and I have, this is also a thing, you need to have a service endpoint enabled on that network. It will enable it for you, but that takes roughly 15 minutes the first time you do it. So I've done that already. Simply click OK. And this might take a little while. While that is working, we can look into the VPN part. So let's say I would like to, oh, now it's done. So we can actually hop into it and look into what it looks like. So now we see that we do have a VNet integration in here. So we can hop into that and well, let's see now. Yeah, so we have a virtual network integration up and running. And if we hop back to the NetSec demo, we can see that we will have another little network interface somewhere. Why it doesn't show? How interesting. It might take a while, but now you will be able to connect to this database straight over the network, and you can shut down all other access. So the next part, I see we are running a little bit late. I will just show you how to create a VPN gateway to easily access this. So basically you search for virtual network gateways. Okay, I already have one, so that's a good thing. I can show you how you configure it from there. But to create a virtual network gateway, it takes roughly 45 minutes. So you simply give it a name, like VPN gateway. We place it in Western Europe. The connection type should be VPN, and this is based if you are running a Ipsec Tunnel. This is based on what sort of device you have. If you're running point to site, you should have it route based. And if this is just for management, set it to basic, 25 euro-ish, 100 megabit. And then you simply add it to your network. And what it will do, it will create a new gateway subnet. You will need to have a IP address as well. So I will just give this the name. The object will be called VPN-GV. Here you have the possibility to utilize active mode, for instance, and BGP. We won't be doing that today. And then you're simply going to review and create. It will go through it, and the deployment will take roughly 45 minutes. So let's skip ahead to the gateway I already have, which is 100 a basic VPN. This is on a different subnet. So what you can do is, let's say you wanted to use Ipsec Tunnel, you can simply add that here on the connections. So what you do is you give this connection a name. So you set the type to Ipsec, and then you have to define something about the local gateway. So you have to give it, of course, this outside IP address and the net, and this is the local address space that you have. So I won't be saving this because then we will be just be sitting here and waiting for that. Back a bit. You will have to enter a pre-shared key, as with any Ipsec tunnel, and the IC level you have to set, and that's basically it. After that, all the routing is set up, all the firewall rules are set up. So basically you have an allow between that subnet that you have defined, the local network gateway, and your subnets within the virtual network gateway. Of course, you can limit those with NSGs. But if you just wanting to do some basic management of the, so let's say a few servers that you have in a network, you can add just a point to site configuration. In this case, that will be an SSTP. So what you will be doing, you will have to create a you could call it a virtual address pool. This is just the address pool that you will be connecting to as a client. And what you have to do next is quite simple. You have to, in this case, since it's SSTP certificate based, you create a certificate pair. You do it however you want to. You enter the root certificate here, and then you simply generate client certificates that you give out to every single user. And then you can download the VPN client here when all that is saved, and you can simply add the client certificate to it. And it's just that simple. You don't have to enter any passwords and whatnot. It's just like that. If you're hopping up in a higher SKU, you will have the possibility to use other protocols such as OpenVPN, L2TP, and things like that. So that's a bit rushed through, but that's the VPN gateway. So I will just show you quickly how we enable just-in-time access. So we go back to the Defender for Cloud portal. We hop into workload protections. And it's thinking, what is this? There we go. And we hop into just-in-time VM access. So let's see now. Not configured. I have the VP2 is not configured. I think I configured VP1 before. So what we will do is simply click Enable JIT. And here comes, now we see we have a bunch of suggested ports. So we have 22. Well, that sounds good. It's a Linux machine. 3389. Well, we don't want that. We don't either want those WinRM ports as well. But we can see there's no IP range. There's a bit of a high hourly range that we can access for. Also, we click this and we click Add, and we give it port 22 again on TCP, and allowed IPs are, we can give it, let's say 1234 / should we say 26 in this case, and the request time can be maximum 1 hour. And then we simply click Add. Oh, sorry. Save. I meant to say. Okay, so that's not a valid IPv4 address. So let's just call it 192.168.0.0. It might be a bad example. That's not a public IP, but so it's just like that. And then it is protected. So now we have actually gone through all the basics. I want to underline this is the basics to protect this environment. So I will go through quickly the last steps we have. So give me a second. So yeah, we have done all this in the basic design to protect our VM based and PaaS workload. Next up is hardening the workload a bit further. So the first part that we can do is DDoS protection. And we need to understand that we always have a basic DDoS protection that the Azure does monitor traffic going in and does have an active mitigation against general DDoS attacks. So we're never completely unsecured against that. But let's say we have a larger application that has attracted some attention from maybe some bad actors. We can actually protect that further, and that's by using the premium SKU, which has a set pricing, roughly 2,200 euros. It's fairly pricey per month. But with that, we get application-based mitigation, which means that we will have mitigation that is over time adapting to the traffic flows that your applications have. And you are activating the DDoS for the whole subscription. So that's good to know. And with this premium, you get also metrics and alerts that you can act on and maybe integrate with your own like system, be that a CM system or whatnot. And you get extensive logs, and you also get a guarantee from Microsoft, an availability guarantee. So if this fails to protect you, you will get service credits for those affected resources. And you also have the access to a rapid response support from Microsoft with this. So I'll just show you really quickly how you enable this. I won't do it because it is really expensive and I don't want to burn through my credits for that. But let's just do a dry run. You search for DDoS as I did. You apply it to sponsorship in my case. Let's put it in the NetSec demo resource group. And I simply give it a name. Let's call it just DDoS Premium in this case. And that's it. Simply review and create, and then you are good to go. And of course, you can configure logs and things like that afterwards, but that's the basics. So if hop into the presentation again, let's hop a bit further. We also have another functionality called the Azure Firewall, which is a stateful and also possibly centrally managed firewall that is applied either through the on a vWAN or a virtual network. So it's a up to layer 7 traffic has the possibility for up to layer 7 traffic filtering, fairly advanced such. But what you also have the possibility to utilize Microsoft Threat Intelligence, meaning that you can act if you want to. You can either report or you can act on threat intelligence coming from Microsoft's whole network and block that. Let's say there is a ongoing attack against various different like systems in that region that can pick it up and simply block those if you let it do so. It is centrally managed, so let's say you have a bunch of firewalls in different VNets, vWANs, and different regions. You can manage those from a single pane of glass. It is highly available by default. It is scalable. You can scale it automatically or manually if you want to. And there's also 2 SKUs of it. So you have the possibility to use a standard SKU and a premium SKU. And the premium SKU does have, among other things, signature-based intrusion protection systems. So with a whole bunch of signatures to go for. And of course, like any other a decent firewall. It does have north-south and east-west protection, traffic inspection. So yeah. So that's quickly about the firewall. So I will quickly go through the last bit of the last thing here. That is the web application firewall, which you use to protect your web applications. But to understand the web application firewall, we need to understand the web application gateway, or simply the application gateway. So the application gateway, to put it simply, it's a reverse proxy that can do a whole bunch of things. It can terminate TLS or SSL. You can do load balancing, of course, for it. You can do up to layer 7 load balancing on that thing as well. You can enable session affinities with cookies, for instance, and you can allow a whole bunch of rewrite rules on it as well. So let's say I have a web application where I save the WordPress, where I have 2 backend servers for the WordPress, but images I want to have / images to another pool of servers that's only contained in those. So what I can do is do a simple rewrite in it, and I'll show you that in a bit, how we do that. But it's a really decent reverse proxy or advanced reverse proxy. And I also want to mention, if you're running Kubernetes, you can actually integrate it as an ingress in AKS, Azure Kubernetes Service. So that's really nice. You can remove that TLS termination, for instance, away from the cluster. That's a bit outside the scope for today. But the thing we're going to talk about today, and we're going to enable today, is the web application firewall. It's always based upon an application gateway. So it's something you can put in front of your application without modifying the code at all. So you're utilizing the core rule set from OWASP, and from that you can do your own rules, custom rules, or you have a whole list of pre-configured rules. So you can do a rule that, for instance, if you have a multi-tiered application with backend with SQL, you can utilize inspection for SQL injections, for instance, cross-site scripting and whatnot. But perhaps you have a web-only machine, then maybe SQL injection isn't that interesting. So you can have these different rules running on it. And as the web application firewall, it is a multi-site. It does allow multi-site policies. So you can protect many, I think it's up to 40 sites on the same instance. So you can have that same ingress point for that. And well, the same goes for the web application firewalls. You can utilize different policies for different sites. And it runs in 2 primary modes. It runs in a detection mode, where it logs all those intrusions and intrusion attempts, and it can set off an alarm, for instance, or you put in a prevention mode, where it does prevent those attacks. So now we are going to do I would say almost a speed run through to actually setting up a application gateway with a web application firewall. So we're going to do application gateways, create one. I'm going to add it to the Microsoft Azure sponsorship and to the same NetSec group. And what we're going to do, we're going to actually take those 2 VMs that we have as backends for this. So in this case, this will be in West Europe. We're going to call it WordPress WAF. And the tier that you have, if you want the WAF functionality, you have 2 tiers, the WAF and WAF v2. In this case, we will use WAF v2, where we have access to the most policies. We won't enable autoscaling to protect my sponsorship, so I will only put 1 instance in this case. Won't be putting it in any availability zone separation. Won't be enabling HTTP2, but we need to set up basic WAF policy, and we will call this, let's call it basic policy. Click OK, and then we need to attach it to a network, and we will be using the NetSec demo where those machines lie. and the let's see now. Okay, so I do have some NSGs here that messes things up, but we can just go through. Wow, interesting. Let's just add a subnet. We'll just call this WAF and see if it likes that better. Yep. So it has its own subnet. There we go. And we have to give it a public IP address because the traffic needs to enter somewhere. So we just call it WAF IP. Okay. The backend, in this case, we need to create a backend pool, which is those two. We call those VP. So now let's see if we can see those machines. Yes, here's the first, the VP1 and the VP2. Of course, you can use an IP address to address those, but remember, machines, if you haven't selected anything else, virtual machines does have DHCP. So they might get other IPs. If you select a virtual machine, it will bind to whatever sort of IP it has. So we hop in and now we have a front end, but we need a routing rule. So now I'm gonna pretend we have HTTPS running here. So the first thing we are gonna do is create the HTTPS listener. So we call it HTTPS. We give it a priority 2 in this case. Actually, I will show you in a second why. The listener will be called HTTPS front-end IP configuration, the public one, the one that we created here, and it will listen on the HTTPS port. So the reason I can't select HTTPS is I need to have a certificate. I don't have one, so we will pretend like the HTTP port 8080 will be the HTTPS. So the listener will then go to a backend target, and that will be the backend pool that we configure with my 2 VMs. And we will put a setting, which we call it simply VP again. This is HTTP, so backend port is 80. So this is not the port in the WAF. This is the port in the on the VMs. So this would be 443 in this case, and you could set the CA certificate here for packet inspection. We won't be doing that now since I don't have one. We can add a cookie-based affinity if you want to. So yeah, we will simply call that affinity that. And we can set some other like timeout settings and whatnot. And let's say that the servers are running another hostname. We can actually utilize a rewrite for that. We don't do that today. We just used whatever header that comes in. So click add, and if we want to do those path-based rules like /images goes to other backend, we can actually use that here already, but we won't be doing that today. So now we have that. That's the HTTPS listener where we want the traffic to go. But people also come in via HTTP, and we don't really like that. So first priority with this rule is that we're gonna have a listener called HTTP. The front-end IP is the same. It listens to port 80 as the HTTP is on, but the only thing it will do is a redirection of permanent 301 to HTTPS. That's all. So to the other listener. So if you come into port 80, we will be redirected to 8080 or 443. So that's the only thing. We have a backend pool, and we can hop over the tags, go to review and create. I see we are running really late, so I apologize for that. This will be maybe 2 minutes more. So I think we will have to skip the WAF rule set. That's what we could do next, is to hop on to the web application into the web application gateway and adjust the firewall policies. Sadly, now we are running out of time, so I will actually hand over to back to Klaus, because you have some some final words. And yeah, so.
Okay, Kim, great job. All right. So now we're in that, and I see that you have the poll up. Yeah, and people see the poll, so now the bubbles are coming in. So please do your best to answer on the poll right away. And the next part, I'll just very quickly show you guys on that note is that go into the Zero Trust security posture and utilize the Microsoft resources on this. The picture in this is enabled with direct click. And the next part on this, on becoming a security expert, Kim, is that your stuff that is going? No, that's Mike. Let's see, it comes out on the on that part. So for that part, one thing is to get certified with the Azure Cloud and 365 security postures. And last part of that is that we have our academy, so you can reach out to your tech data representatives to look into a training path so that you can get into that competencies going forward in your own work on that part. So you see, I can see it on the feed now. So for that, 3 minutes over time with a little production hassle in the end. We thank you for your participation and hope that you will scale and utilize these resources. Anyway, feel free to contact your tech data contact in the countries for any projects you will have with your end customers where you will need our great advice from Kim and his colleagues. So with that, thank you, and we close now. We will be on the chat for a minute.